Students, today we are going to discuss time constants in RC and RL circuits. Consider the first in RC circuits. That means the circuit consists of resistor and capacitor. Here it is a voltage, resistor and capacitor. Now express the circuit time constant in terms of resistor and capacitor values. Circuit time constant in terms of R and C. In RC circuits, time constant, that is circuit time constant, generally denoted as a tau, that is equal to RC. In RC circuits, circuit time constant tau is equal to RC. That means the product of R into C is equal to time. To prove that simple mechanism, proof. RC is equal to time. So R into C, that is equal to, okay, R is equal to V by I. Then substitute here, that is equal to V by I into C. Again, here already we know that in capacitor V is equal to Q by C. From that C is equal to Q by V. Now substitute the condition. V by I into C is equal to Q by, these two get cancelled. Then again Q by I. Again Q is equal to I into T. So from that Q is equal to I into T by I. I get cancelled. So that means the product of R into C, the product of R into C is equal to time. T, that is equal to time. So generally in RC circuits, some other RL or RLC circuits, circuit time constant generally noted as a tau, that is equal to RC. Okay, that is a simple derivation in RC circuit. Once again, here in RC circuits, circuit time constant. What is the circuit time constant? That means time constant expressed in terms of circuit elements. Here RC are the circuit elements. Express the time constant in terms of RC. Here in RC circuit, time constant is equal to R into C. This is a simple proof. Simply substitute R is equal to V is equal to C is equal to and Q is equal to. Then after few steps, 5 to 6 steps, we prove that the product of RC is equal to time. So final conclusion is in RC circuit, time constant is equal to RC, product of R into C. Similarly, RL circuit. In RL circuit, what is the circuit time constant? Circuit time constant in terms of L and R. In RL circuit, time constant tau is equal to L by R. Whereas in RC circuit, tau is equal to R into C. Whereas in RL circuit, tau is equal to L by R. To prove that L by R is equal to time. Okay. Then already we know that well known in inductor V is equal to L di by dt. From that I is equal to 1 by L into integral minus infinity t into V of t into dt. If this area is constant, this is V of t is constant, V of t is constant, then I is equal to V by L into t. Then from that L is equal to V by I into t. Now L value is equal to V by I into t. V by I is equal to R into t. So V by I is equal to R. Now by using that one, L by R is equal to t, time. So in RL circuits, time constant tau is equal to L by R. The final conclusion is, first one is, in RC circuits, tau is equal to R into C, whereas in RL circuits, tau is equal to L by R, where tau is equal to circuit time constant. Circuit time constant, the units are seconds. So these two are the time constants in RC and RL circuits. Now problems on initial conditions. Here this is the given circuit. Given circuit is a RL circuit, resistor, inductor. Here there is a one switch. In transient analysis, there is a one switch. Switch is closed at some particular time instant. Here the given problem, yes, switch is closed at t is equal to 0. When switch is closed, 10 volt source is connected to the RL circuit. When switch is open, it is not connected to the RL components. Now here this is the given data. Voltage is equal to 10 volts, R is equal to 10 ohm, and inductor value is equal to 1 Henry. And this is the initial current. Initial current I of 0 minus is equal to 0. S is closed at t is equal to 0. Then the problem is, find current I flowing through the circuit, di by dt and di square by dt square at t is equal to 0 plus. Right, here the solution is, first of all, we have to draw the initial condition circuit diagram. The problem can be solved into three cases. First case is t is equal to 0 minus, and second case is t is equal to 0 plus, and third case is t greater than 0. But consider the three cases. T is equal to 0 minus, what is the equivalent circuit diagram? Then find current. Similarly, t is equal to 0 plus, equivalent circuit diagram and current. Then third one is t greater than 0, draw the equivalent circuit diagram and find the required parameters given in the problem. Here the first one is t is equal to 0 minus. Here in the given problem is, what is the initial condition? I of 0 minus is equal to 0. That means initial current through the inductor is equal to 0. Now the equivalent circuit is, switch is open, t is equal to 0 minus. Now inductor becomes like a open circuit. Here this is the L is 1 Henry and this is R 10 ohms. Here the given is I of 0 minus is equal to 0. current is equal to 0, inductor behaves like a open circuit. When open circuit there is no current, so that I of 0 minus is equal to 0. So that current flowing through the circuit is 0. That is the first case. And coming to the second, t is equal to 0 plus. Okay. Now the equivalent is, and S is closed at t is equal to 0. So that switch is closed. This is resistor, and in this case also inductor behaves like a open circuit. Again here also I of 0 plus is equal to 0. Why? Because in inductor already we described initial condition of inductor, I of 0 plus is equal to I of 0 minus. That means inductor does not allow the sudden changes. So that I of 0 minus is equal to 0. So that I of 0 plus also 0. Again current is equal to 0, it behaves like a open circuit. Now coming to third, this is the second case. Okay. And third one is t greater than 0. Whenever t greater than 0, here switch is closed. Here it is 10 ohms. Now here it is inductor 10 ohms. Apply KVL to the loop. Apply KVL to the loop. Then V is equal to current I into R plus voltage across inductor is equal to L into di by dt. And substitute values here. 10 is equal to I into 10 plus L value is equal to 1 into di by dt. From that, di by dt is equal to di by dt is equal to 10 minus I into 10. Okay. In terms of expressions, okay, here it is expressions. Di by dt is equal to V minus I into R. Okay. Now we have to find the current I, and di by dt, di square by dt at t is equal to 0 plus. Right. Now here this is equation 1. At t is equal to 0 plus, that is di 0 plus by dt is equal to V minus R into I 0 plus, that is equal to V is equal to 10 minus R into I of 0 plus is equal to 0, that is equal to 10. So di 0 plus by dt is equal to 10, where the units are amperes per second. Similarly, find di square by dt square. Next, another one is di square by dt square at t is equal to 0 plus using the equation di by dt is equal to v minus I into r, di square 0 plus by dt is equal to, differentiate above equation, suppose one, this is also one, differentiate with respect to time 0 minus r into di 0 plus by dt, that is equal to 0 minus r value is equal to 10 ohms. Already we calculated di 0 plus by dt, that is equal to 10 into 10, so minus 100 ampere per second square. This is di square 0 plus by dt square. Okay, like that, this is the problem. If the given is voltage source, one switch is closed at t is equal to 0 and two components resistor and inductor. Switch is closed at t is equal to 0 and initial condition is initial current to the inductor is 0. Then find the current at different cases and also find the di by dt and di square by dt square at t is equal to 0 plus. Okay, here t is equal to 0 minus I of 0 minus is equal to 0, so that current is equal to 0. T is equal to 0 plus, that is equal to I of 0 minus also 0. Then t greater than 0, write KVL equation. Then di by dt is equal to v minus IR. From that again find di by dt, di square by dt square at t is equal to 0 plus. Then di by dt v minus IR at t is equal to 0 plus. Then substitute values, we will get that di by dt 0 plus is equal to 10 ampere per second. Di square by dt square at 0 plus is equal to minus 100 ampere per second square. The next problem, consider the second problem. The second problem here is the component is, circuit components are resistor and capacitor, whereas previous circuit resistor and inductor. Okay, data is almost same. Voltage is equal to 10 volt, resistor 10 ohms and capacitor value is 1 microfarad. And here the initial condition is initial voltage cross or through capacitor is equal to V of 0 minus is equal to 0. Then switch same as previous, S is closed at t is equal to 0. Find current and di by dt and di square by dt square at t is equal to 0 plus. The solution also same as previous, t is equal to 0 minus, t is equal to 0 plus and t greater than 0. And coming to the first one, t is equal to 0 minus and status is S is open and V of 0 minus is equal to 0, then I of 0 minus also 0. Then coming to the equivalent circuit, when voltage is equal to 0, V of 0 minus is equal to 0, here the capacitor act as a short circuit. Here 1 microfarad capacitor act as a short circuit and here the switch is open, so that I of 0 minus also 0. Here the capacitor is short circuit. Why? Because voltage is equal to 0. Because voltage is equal to 0 and I of 0 minus is equal to 0. And coming to the second case is t is equal to 0 plus and S is closed. Based on initial condition, V of 0 plus is equal to V of 0 minus. Okay, here first of all draw the equivalent circuit, and the equivalent circuit is S is closed, then this is resistor R, and again here capacitor. This capacitor is short circuit. Why the capacitor short circuit means V of voltage across capacitor, V of 0 plus is equal to V of 0 minus, so that capacitor act as a short circuit. Now the current is equal to, now the current in the circuit is equal to, I is equal to V by R, that is equal to 10 by 10, that is equal to 1 amperes. So in second case, I is equal to 1 ampere. That means at t is equal to 0 plus, I of 0 plus is equal to 1 ampere. That is the second case, right? And coming to the third case, is equal to 0 minus 0, I of 0 minus is equal to 0, I of 0 plus is equal to 1 ampere. T greater than 0, the status is S is closed, and draw the equivalent circuit. Then apply KVL to the loop. Apply KVL to the loop. Then V is equal to I into R plus voltage across capacitor 1 by C integral I dt. Then differentiate with respect to time. Then V is constant of differentiation, 0 is equal to R into di by dt plus 1 by C into, that is equal to I, and by C into I. Now this expression is equal to, now substitute values here. R is equal to 10 ohm, C is equal to 1 microfarad. So di by dt is equal to 1 by RC into I. So di by dt 1 by C integral R dt, differentiate. Okay. Di by dt is equal to 1 by RC into I. Now find di by dt at t is equal to 0 plus. At t is equal to 0 plus, di 0 plus is equal to, and substitute the values, and R value, C value 1 microfarad by 10, and I of 0 plus, that is equal to 10 to the power of 5. I of 0 plus already calculated, 1 ampere into 1 ampere, that is equal to 10 to the power of 5, and units are amperes per second. So So di 0 plus by dt is equal to 10 power 5 ampere per second. Then again at t is equal to 0 plus, find di square 0 plus by dt square. Again consider the same equation. Differentiate equation 1 so that di square 0 plus by dt square is equal to 1 by RC di 0 plus by dt. Then values are di square 0 plus by dt square is equal to minus di by dt is equal to minus, corrections are minus, here also minus, here also minus, here also minus, so that minus 1 by RC, already you know this value, di 0 plus by dt, that is equal to minus 10 power 5, that is equal to 10 power 6 by 10 into minus 10 power 5, so minus minus plus, minus 10 power 5 into minus 10 power 5, that is equal to 10 power 10 ampere per second square. So di square 0 plus by dt square is equal to 10 power 10 ampere per second square. Okay. Coming to the problem here, the given problem is resistor and capacitor. The procedure is same as previous procedure, and S is closed at t is equal to 0. Find currents on di by dt and di square by dt. And here the important one is, whenever we go for differentiation, we have to calculate the future values, right? Then t is equal to 0 minus, the previous voltage is equal to 0 and I have 0 minus also 0. Then t is equal to 0 plus, and here the value is, when we calculated, that value is equal to 1 amperes. And t greater than 0, when switch is closed, here apply KVL to the loop and simplify, and finally di by dt is equal to minus 1 by RC into I. Then at t is equal to 0 plus, di 0 plus dt is equal to minus 10 power minus 5, I of 0 plus is equal to 1 ampere, that is equal to minus 10 power 5 ampere per second. Similarly, at t is equal to 0 plus, di square 0 plus by dt square, and again we calculated and simplified the value is 10 power 10 by ampere per second square. Like that we have to, with the different values of resistor, inductor or capacitor, we have to find the initial values. These problems are initial conditions, right? Based on this procedure, I request all the students solve the different problems with the different values of resistor, capacitor and inductor. Thank you.